Thank you all for coming to the DHEP today. This is our 10th DHEP for the series. To introduce our speaker for this afternoon, she questions how people sense, understand, and learn about the world around them in their day-to-day life, especially as related to emerging technologies. That question has underpinned her work since she received her PhD in educational neuroscience from Gallaudet University in 2023, where she investigated the role of the brain's predictive processing in deaf signers' perception. Through a collaborative NSF-funded signing avatars and immersive learning project with Dr. Lorna Quandt, her research has found that deaf signers have enhanced perception and understanding of natural human movements in both sign languages and everyday actions. Through this work, she has been a co-author on 8 published articles in Cognitive Neuroscience and Human Technology Interaction. Currently, she is part of the Rochester Postdoctorate Program with Dr. John Foxe in the Cognitive Neurophysiology Laboratory at the University of Rochester Medical Center. There, she's continuing her investigations on how sensory, language, and social experiences impact the neural development of multisensory perception in intellectual and developmental disabilities populations, such as people with autism spectrum disorder and deaf people who have experienced language and social deprivation as a child, with the future aim of producing meaningful and community-driven translational approaches with clinical technologies such as virtual humans, AR, VR, and artificial intelligence. Please give a warm welcome to our speaker today, Dr. Athena Willis. Hello, everyone. I'm so happy to be here today to share my experiences and my journey in getting my PhD. So they invited me here to talk a little bit about my research, and I'll talk a little bit about the new science that I've been working on, and then I'll also talk about my experiences and how I got my PhD. It was a long and not necessarily easy and a little bit strange process. So first, before we jump into my presentation and my upbringing, I want to share a little bit of neuroscience knowledge. So a lot of people think that the brain is basically everything. Let me see if my clicker is working. Okay. So people think that we can look at the brain independently and see a person's thoughts, their experiences, their abilities, and see everything that's going on in the brain. But still today we know that's not true, because the brain actually looks more like this. The picture on the right. So the brain is connected throughout our body, and the brain cannot exist independently of our body. In fact, everything is interconnected, and all of those neural systems affect how we think about what we're doing and how we experience our daily life. So I want to explain my experience through my PhD program, because many people think if you don't have the right things in your brain, you'll fail, but really it depends on your experiences. We develop our abilities by making mistakes and by learning from them, and that's how we are eventually successful. So that led me to develop my title here, My Body, Our Brains, and the Eyes for the Future, and my experience doing research with perception and neuroscience and developmental disabilities. I also want to let you all know, just to be transparent, that I will have Q&A at the end, but I'm also open if you need clarification or if you don't understand something I say, please raise your hand and let me know, and I'll be happy to clarify during my presentation, and then we'll hold the rest of the questions for the end. So first, let me explain what we'll talk about today. There are 3 parts to my presentation. The first is my body, meaning looking back on my upbringing, what led me to where I am today. I'll talk about my childhood and how I navigated some of the different turns in my path along the way. And then we'll talk about my PhD my academic experience and how I got to my current research project. I'll also share some tips that I've learned along the way about what science looks like. And I'll also talk about, I've learned a lot about not only how to do science, but also how to work with other scientists. Because science is not an independent work, it's really a social thing. And then at the end, I'll talk a little bit about the eyes for the future, so what the future looks like, and how can we make sure that everyone can succeed, and how all of you can succeed with your goals, whether it be PhD, your careers, academia, whatever else. So I'll start with the first part here, my body. So looking back on my childhood, today I know more than I did growing up, so I can look back on it and remember some things that happened that seemed a little bit odd at the time, that I didn't realize what was happening at the time, but now I can look back and understand better. So I was born and raised in the Midwest in Indianapolis. That's a picture of downtown Indianapolis with the skyscrapers. That's our signature skyscraper with the 2 antennae on it. I went to a mainstream school, but my parents were both from very small rural towns in the Midwest. And they both only completed high school. They never went on to college. And my grandparents on both sides also had unique experiences. My grandmothers on both sides grew up in the middle of nowhere. And then my grandfather on my father's side was adopted as an orphan at 12 years old. And so that affected how they worked with me and my father's experience raising me. And then on my mother's side, my grandfather moved here from Ireland when he was 12. So I'm my mom was a first-generation American. I'm a second-generation American. That did affect how I grew up, but that also affected how I viewed the world and how I view the world now. Both of my parents were hearing. They didn't know sign language. I was born hearing but became deaf when I was 2 years old. And from that point, really, that was in 1992. My parents didn't know what to do with a deaf child. They had no idea. Today, obviously, the advice is to learn sign language, but back then they didn't have access to that kind of information. So first, my father brought me to a doctor my father noticed that I wasn't maybe hearing right, and my doctor told them that I was deaf and that I would never be able to learn to read. But my father didn't trust the doctor. He had had bad experiences with doctors growing up. So he didn't believe the doctor, and he brought me to a different doctor. That doctor shared different information and encouraged me to go into a school that had sign language interpreters. It was signed exact English at that time. So I ended up mainstreamed with a group of deaf and hard of hearing classmates. And that mainstream program was really started more for hard of hearing students. So it focused on students with some hearing who also use spoken English. But for me, I was also in the first group who received cochlear implants. And that hospital didn't really know exactly what they were doing. They thought that getting a cochlear implant would lead to absolute perfect hearing and full access. Obviously, that's not true. So I was put in this mainstream program, but I really relied on sign language. I had interpreters in my class, and I had deaf and hard of hearing classmates, but I was still missing some connection with them. I didn't always get along with them very well, because first, in a big crowd, you always want to have, options to develop relationships with different people, but they just weren't great people. I didn't really like them. We never really got along. So it was socially iffy. Some of my hearing peers were nice, and I was able to connect with them a little bit. But with the other deaf and hard of hearing students, I just always struggled. And without that community, what I did instead was I read. I read a lot growing up. And I think today, looking back on this, I think people would notice that I was smart because I read a lot, and that might be true. But I think what was really more attractive to me was video games. Video games, Calvin and Hobbes, especially once the internet came out, there were, games that you could play, multiplayer online games, and that was a huge social experience for me. Through gaming, people didn't know that I was deaf. And so that meant that I could just focus on playing the game. And I might have had bad social experiences, but I was able to learn from them and then apply them to the real world. And that was very beneficial for me in being able to develop those social skills. Because again, many of the mainstream deaf and hard of hearing students didn't have access to that kind of socialization outside of school, and that was very powerful. So I went through mainstream school all the way. I graduated from high school from that same program, and then I went to Butler University. For some reason, they liked me. I still don't know why, but they liked me. I got a few letters of support, and I was able to get a scholarship for Butler University for a lot of money for me to go, $120,000, which was a lot of money. It was a little bit ridiculous, but I was able to get it. I went to the university, and I went through 3 years, and then I burned out. I failed out after 3 years. It was really an awful experience. And when I look back on that and why I burned out, I think it's because the mainstream school that I went to growing up was really similar to the people that I went to university with. So those socialization opportunities I had in mainstream was actually very different from the people who I met at university. So at university, I had a lot more positive social interactions in school that led to more success, but I still ended up burning out. I dropped out. And this is sort of a weird sidetrack, but you can see here in the picture. Can you tell what this is? Meats. Yep, some kind of meats, cured meats. Yep. This is called a dry curing room. So if you're familiar with things like salami, typically goes through multiple months of curing, and it requires the right amount of salt in proportion to the meat. And then there's a specific fermentation process that creates acids within the sausages, and that helps promote the longevity. And so they stay in this room for a few months, they cure, they dry, and we had 3 different processes for different products, and it was delicious. So that's what I learned at this stage of my life, because after I burned out from college, I didn't really want to do much. I couldn't read. I couldn't really think about the future. I, rode around with my father for a year, and my father had a vending machine business. So I was able to ride around with him and help stock vending machines. The vending machines that you see, everywhere that you can get snacks from. We would just drive around and restock those vending machines. And after about a year of that, my dad wasn't great to chat with, so we would ride together kind of in silence. He didn't feel comfortable signing. And, even with more updated cars and technology, he didn't really teach me that much because we couldn't communicate very much, so it wasn't very exciting. After that experience, I worked at a few different restaurants, and I learned some really cool things. I got really into food, and that led me to another experience, which was that I interacted with a lot of hearing people who didn't know sign language. We were working together, making food, cleaning, doing all that restaurant work for, 45 hours a week together. And I noticed a lot of people, people had different abilities in communicating with me. Some people didn't know sign language, but they were really easy to communicate with. Other people didn't know sign language, and they were kind of freaked out about working with me. They would work with me, but they kind of kept their distance, or they didn't, they just weren't very friendly to work with. So I noticed those 2 different types of social interactions, and that made me really curious. And part of that may be related to deaf culture. A lot of people assume that deaf people are less smart. People who use sign language are less smart. And based on prior experience, that leads people to certain conclusions and stereotypes. But that affects how they interacted with me and the relationships that I was able to build with them. And I worked at different restaurants for probably 3 to 4 years. And then I got to the point where I was thinking about opening a meat shop with my best friend who didn't know sign language, but we were very close friends. And I I wanted to go ahead with that, but I wasn't sure what would change for me. I would still be stuck in a work environment with predominantly hearing non-signers, and I didn't have a sense of community. So at that point, I felt like I had had a unique experience where I realized that I wasn't happy with my work life, and I realized that I wanted to do something more. And so I thought to do something more, I thought about what I could be able to do. And as a deaf person who uses sign language, I knew that I would have a challenging time finding more opportunities. So I thought about what to do, I strategized about it, and about 3 years after I dropped out, I had had no connection with academia. People didn't really know me, I didn't have any money, restaurants don't pay well. So I decided to go to community college. I went to a community college for 1 year. I got all A's, and then I got a good letter of recommendation, and I decided to apply to Gallaudet University. They offered me a full scholarship.
And so I went back to school for neuroscience. So I just wanted to share with you my experience that I went through as an undergrad and what I did to get through my PhD program, just so you have a better idea of who I am and what I do. So my work is related to one-handed signing and two-handed signing. You can sign the sign cat with one hand, but the sign for butterfly requires two hands. But both of those processes take place in the brain. Now, we use the EEG patterns, and they typically show color. So the picture on the left shows one-handed signing. The blue color shows the power of the synapses and the work that's going on in your brain. Towards the right, with two-handed signs, you can see similar colors. But it's also using both parts of your brain. So by doing this, we can identify whether the sign a person is seeing is one-handed or two-handed just by looking at the colors from the EEG. So I didn't do this project from scratch. I worked with my advisor, Dr. Quandt. And together we worked in MATLAB to develop some analysis through EEG. And honestly, that is a really good skill that I developed initially because I've been using it since then. So this was really good foundational work for my future work. Here's another project that was an REU program, Research Experience for Undergrads, in Information Technology. This was developing an academic journal in ASL because a lot of the academic information is written in English. And we don't really have access to a lot of those academic journals unless they're published in ASL. So this was a pretty cool project that we worked on. Then we were developing a new technology of sign language using VR. And this required a principle called embodied learning. And that means that we use prior experience, prior perceptive information to inform future events. So embodied learning really relies on natural human movement, and that's based on prior experiences we've had, things that we've viewed in the environment. And sign language is a language, and so people think that maybe we don't necessarily rely on this embodied learning. So we worked on this project, became part of my dissertation, and this informed our research discussion. So we created some signing avatar programs, and they were made with human models. There is another type of avatar that uses the language but is missing that human connection, and the movement is more awkward. One of the avatars is made through motion capture, and it's more human-like. And so basically we found that humans use prior experience to help them to perceive and understand avatar movement. This was really important information because it shows that when we are perceiving language, we are using our prior experiences to inform our perception. And our needs and intentions as well. So beginning in my undergrad, I worked on several projects that helped my understanding of human movement, and I've published several articles, and now I'm working on an additional project on how deaf people who have been language deprived and how that creates a foundation for their socialization. So I'll talk a little bit more right now about my current research and my experience working in science. So the picture you see here on the right, it says there's a sign on the front that says RISE. That's actually one of the schools I went to as a child. You know, honestly, I had to ride the short bus because I was mainstreamed. But the school I went to was farther from my home district, so the short bus came to pick me up every morning. And there I met other students with intellectual and developmental disabilities, and I didn't really connect with them. I wouldn't call them my friends, but I did realize that people consider them different or disabled. And I had never worked in sign language with scientists or anyone else like that, and I realized that they viewed them in a different way. So I realized that the term disability is nuanced, and there's a range of disability, just like there's a range of deafness. It's not binary. There is no this or that. There's always a spectrum. That's what I'm working on now in my current lab. It is the Cognitive Neurophysiology Lab, and they work on sensory perception because today we know that people who are lacking in sensory and perceptive skills don't lack intelligence. The brain is continuously predicting potential events, potential reactions, potential actions. And in order to do that, in order to react, the brain has to be able to predict and perceive. So it's not just about taking in information and processing that information. Your brain also can project prior information in order to inform predictions and reactions. And your brain then can identify differences from that. So I think this is really cool work. I have an example for you. People who have ASD, autism spectrum disorder, typically they struggle with social activities. They might feel awkward in a situation, but the research is finding that really they're much more sensitive to sensory information, and that's what the recent research has shown. If there are sensitivities to multi-sensory issues, or they actually take in information faster and better than a person who is taking in information just auditorially or visually. And that's actually very common, but in people who have ASD, it's not there. That's something that is missing. And they're actually very good at taking in information better in one sense than neurotypical folks. So these folks have unique abilities, and it does not mean that they're not intelligent. But we're looking into why that kind of thing happens for my PhD research. So it's perception regarding taking in information. So we work with high-density EEGs that requires putting nodes on the scalp. They receive sensory information, and we investigate how the brain responds to that stimuli. So that was my first project. My second project has to do with body movement and perception. Specifically looking at body movements and taking in sensory information from that and from people in the environment. So that means that we need to pay attention. We need to be able to recognize things in people, because then your brain is able to prioritize information. So I may be focusing on my computer, but I can also see across the way someone enter the room. And that's just something that happens. I'm focusing on the computer, and that doesn't necessarily mean I'm going to miss a person walking in the room. I could. Someone could come into the room and get my attention in a certain way. But that also is called social information. So our question is to see if people who are socially deprived have the same type of reaction as a neurotypical person. And whether that sensory input is the same or different. So that project is ongoing. So that's my ongoing work right now with social and language deprivation, to see if people have access to language and then they don't have access to social opportunities, what impact that has. We know that language deprivation is an important aspect of lives, but social deprivation is as well. Opportunities to have friends and be with people do impact our brain development throughout our childhoods and as adults. So now I'm working clinically in the lab. And now I can see what doctors are saying about people. It's not always great, but that's my current work. So now my thoughts on doing science with others. So the image on the screen is really representing a network of people. But also, In science, you have to do a lot of networking. You have to do a lot of connecting with people, and a lot of work and research is related. One thing I've noticed is that scientists have their own culture. It may not always be obvious to everyone, but it seems that their culture is that people have implicit knowledge and take on their own education for themselves. There are some scientists whose parents did graduate from college and maybe continued on in their academic careers at a higher level. And they were able to provide their children with the added benefit of shared knowledge, teaching them their curriculum and sharing with them the knowledge that they already had in order to get through that. So they already have this social framework of information. Navigating this social hierarchy is not always easy. It can be an interesting experience. It depends on the lab. It depends on the investigator you're working with. It depends on their view of you or their view of me. And it's not always easy to navigate and get through that experience. It's nice when you are able to develop friendships and connections with your peers. So really, that's my experience with doing science. And I would say you have to be able to develop connections. So just speaking with people isn't enough. Just talking about your subject area is not enough. You have to really connect with them in order to build your foundation, your network foundation for the future. So also this when I worked in restaurants, that actually helped me, even though they didn't sign. Even my school experience helped me in the lab. Social skills are the same no matter what program you're in, no matter where you are, but really it's important for us all to connect with people and make friends.
So for the end here, I'll talk about my thoughts on what I've talked about so far, and then also what we can learn and apply for the future. If you remember earlier, I said that your brain is not just this, disconnected brain in your head, but it's actually interconnected with your body and with everything that you do, all of the actions that you do. And not only that, the interactions that we have, but also the interactions that we see other people have. So if you don't have that experience, then you can't necessarily successfully navigate through your future. You have to have those experiences. And thinking about people who do science with people who have intellectual and developmental disabilities or people who are deaf, those scientists don't necessarily have the same experiences that we do. So they can't necessarily understand or predict what our brains and bodies can do. I don't think they can. They can try. They can have some research findings, but I don't think that they can fully experience what it's like or fully understand the unique experiences of different populations, like people with IDD or people who are deaf. Without having that lived experience, you can't fully understand that. Your brain is your body, and you have the potential to act and do. Those things are connected. Just a question for thought. For example, with deaf people, we already know that a lot of money has been spent on research and very powerful neuro research on how to cure deaf people. That's been done for hundreds of years. It may have had some successes along the way, but we know now that it's not just about being able to hear, but it's about being able to access language, being able to access socialization. And it depends on what your environment looks like as a child. Because we recognize that children have a critical period where if they don't have access to language, either sign language or spoken language, then that critical period can close and they experience language deprivation. But what if medically we could reopen that critical period? What if adults who had experienced language deprivation as a child could get a second chance at acquiring language? Would that solve their problems? What do you think? Any thoughts? Maybe some yeses? I don't think so. I think that critical period could be reopened, but they still need community. They still need socialization, and they still need friends. So if you open that critical period, it really nothing would happen, and I think they would just stay the same. So that's one thing to think about. And as my research continues, I've been thinking more about that, because research is showing that there may be medication available out there that could reopen that critical period. But even if that were true, would that actually be beneficial to use? Or use without a community or socialization to support those folks? I don't know. I don't necessarily want to say that people are lost forever, but what would we do with them to support that reacquisition? And I mention that because that's the type of future that I'm thinking about. I'm thinking not only about children who are very important, but there are also so many adults out there who really lost that opportunity. And I don't want to say that they are lost, but they are in our community still. They're still people. And they're still our family. So are we working on that future? Are we ensuring that everyone can be part of our community equally and work together? That's another question for thought. So a question for you to think about. When we think about doing science, what do we envision that process looking like? Any thoughts from the audience? What do you think science does? What does that look like? If you want to go up. Asking questions. Asking questions, that's a good one. Yep. Collaboration. Yep. Yep. Right? Oh, in the back. Many disciplines. Yep. Yep. Yeah. Yeah, those are 3 great ideas. I would just add a basic process of what people think science is. So the idea is you have a question, and then you think about how we can answer that question. Maybe that's by collecting data. We have to pick the right variables, set up the data the right way, analyze the data we collect, and then interpret it. And then we write a paper about it. We submit the paper to reviewers. The reviewers read it. And the reviewers are experts in that specific area. They read the paper, they review it, make some comments, and then hopefully they publish it. But science isn't really like that. First of all, science is science, but if you look at it more specifically, people who do research in specific areas typically know each other. They already know what people are working on. They are already anticipating these publications because they've seen those people present their work at conferences. And if they don't like you, then they'll be able to recognize it and they'll criticize your paper more. It may not be necessarily related to the science itself, but it could be something simple like that's the wrong formatting, or the hypothesis is in the wrong spot in the paper. It should be in a different section. And those type of responses, that is social. Many people think that science is just pure data collection, interpretation, and then presenting results, but it's not like that. Before we get to the point where we can even collect data, much less publish it, we need to have that social development and those connections with other people in your field, with your peers. And with peers, you meet those peers through classes, through academia. You should be supporting each other, and then also through your PIs, the people running labs that you want to work in. You have to make connections with them as well. If you make those good connections, then you can be successful. But then if you go to a conference with people in your area, experts in your area, those are the reviewers, those are the people who will be reading your grants and papers that you submit. And so you have to have connections with them. And you can try to connect with them, but there's always a question of whether they will connect back with you. And if you keep trying to connect, but you're not building those connections, then that may just not be the right person. And that's the reason I mention this. If you want to do science, you have to be aware of who you want to work with. And when you're interacting with someone, if you feel like they're judging you, bullying you, waving you off, if the vibes are off, then don't give them your time or energy. And especially something I still see today is having a PI who bullies their students, and everyone knows about it, but students still go to them. And that's a mistake because as the PI, they're doing research themselves, but they are too busy to do all that research on their own. They need to have other people and students doing research for them. But when there's mentoring, then really we should just leave them on their own. If people do research with a mentor, the research is beneficial for the mentor too, because you're doing research that contributes to their paper and their grants so that they can get more money to be able to continue to do science. It's a reciprocal relationship. So if that relationship isn't going well, and if you recognize that you're not the only one, but there are lots of people feeling that way, then avoid that person. That's my biggest advice to you. You really have to build good social connections with your PI and your lab mates because they will be your future collaborators. And then also, think about the goals that you have. For example, I'm sure that a lot of you want to have a deaf mentor. Obviously, that's great. That's very cool. I wanted the same thing in the past. But when the time comes, when I was applying to grad school, I considered my possible mentors, and I asked them one simple question. You know, deaf people go to conferences, they struggle to get interpreters, they struggle convincing the conference to provide interpreters, or maybe if they're able to bring their own interpreters, they're not able to use them for the full conference, or maybe the conference provides interpreters but not for social events. So knowing that situation is very common, I always asked if I go to a conference and if I'm in that situation where I don't have enough interpreters, I don't have good interpreters, and I'm not able to connect with other researchers, what would you do? The first one said, I don't really know. The second one said, I really don't know. And the third one also said, I don't know. Those three were all deaf researchers. And then the fourth was a new faculty who's hearing and learning sign language. And that person said, well, I would join a committee for the conference. I would join their board, I would go to meetings, and I would advocate for the conference to get more money, apply for more money for access services. And I thought, okay, all right. Because for me, when I was, maybe I was 25, I picked that person, and that was my advisor, Dr. Quandt. Because even though she hadn't experienced those frustrations, those experiences struggling with conferences to get interpreters, she was pretty naive to that situation. But she knew how important it was to socialize with people. She knew how important it was to convince conferences to change their approach and to provide interpreters for social events. And it's important to put the money where your mouth is. So that strategy, helping get to the point where you can actually attend conferences, rather than going to conferences but missing out on those opportunities, her being willing to join committees and advocate for conferences, that is so important. And many of us don't go to conferences anymore because they still don't provide us with those opportunities, and they don't recognize how important it is to have interpreters for social events where you make those connections that make you a successful scientist. So be open to unexpected opportunities, because sometimes you may not anticipate those, but those opportunities lead to more opportunities. And you can envision a plan for yourself, but sometimes you have to be open to other ideas too. I like that advice the most. That's definitely led me to some cool opportunities. For me, growing up, I had expected, looking back on it, it would have been nice to go to a deaf school. That would have been cool, but that didn't happen. So instead, I immersed myself in reading books, playing video games, other hobbies. And I ended up playing social video games where I was able to develop that social experience that helped lead to where I am now, to be able to navigate school and life and whatever else comes my way. And being able to share that with you, and being able to get a PhD in neuroscience. And I know that you're all in different science fields, but that's the best advice I can give. Recognize how important it is for social connections and be open to unexpected opportunities. So, not bad, 45 minutes. I think that gives us some time for Q&A. I do want to thank the RPP, the Rochester Postdoctorate Program, who gave me the opportunity to come to Rochester and do work with Dr. John Foxe's lab. Without the RPP, I wouldn't have that opportunity to work with, really, Dr. Foxe's lab is very well known and very prestigious. So I'm grateful for that opportunity. And then also people in the lab are very nice. Many of them are hearing, some of them know sign language, but they've shared a lot of good information with me. I've made good connections, and they share great resources with me. I also want to thank my PhD advisor, Lorna Quandt, for being willing to work with me. And we really did go through a lot together. It wasn't always perfect. There were frustrations on both sides, but we got through it. I also want to thank another program called the Neuroscience Scholars Program, which is part of the Professional Society for Neuroscience. They recruit underrepresented populations, students from underrepresented populations, to do research. So they focus on people of color, Black people, but also neuroscience, people in the field of neuroscience with disabilities. And they gave me an incredible experience. I made a lot of great connections and got a lot of good advice from other people who may have been, the first Hispanic woman in neuroscience in her university, the first Black man in his university to specialize in a certain area of neuroscience. I didn't expect to connect with them as much as I did, but those connections were invaluable, and they gave me great career advice. I don't think I would have been a successful deaf researcher without them. And then I also want to thank NTID and DHEP for inviting me here today. Thank you. Okay, I'm open for questions. I have a comment and question. I really like that you talk about science being social, because graduate school especially is very emotionally difficult. It was for me. I had an advisor who actually listened to me at that time, and I made some friends that I could depend on in that process. So in addition to your advisor, where was the best place to look for friends and support? That's a great question. So my PhD program, the Penn PhD program, PhD in Educational Neuroscience, is very, very small. When I was there, there were maybe 5 other PhD students. So it's a very small, very intimate group. So it's nice to find support in that cohort. But then I also met a lot of new friends through conferences too. The NSP, the Neuroscience Scholars Program, gave me the opportunity to meet several other people. And we regularly got together. We had socialization opportunities. I can't say that I instantly made connections, but if you just take time to show up and be there, then you can try to make those connections. And I think that's really nice. I know sometimes it can be surprising for people who are experts, who have PhDs, from Yale or Harvard or whatever else it may be, to be really curious about you and want to make that connection. But that's where you can make those connections that will help develop your science and your networking. Your research area is very interesting to me. And so now I am thinking of two questions. First, you're in the RPP, right? You're currently a postdoctorate fellow. After that, what do you plan to do? What are your thoughts after the RPP? And my second question is, because you've worked on so many different and diverse projects, what is your dream project for the future? Thank you. That's a great question. So I am in the RPP. I know with everything going on the last 2 weeks and some of the threats to NIH, I don't know how long the RPP will continue. So I'm actually thinking a lot right now about my next steps instead of waiting until the program ends this summer. I am trying to find strategies that will keep me in academia, which means I'll probably look for another postdoc, maybe in a different lab or the same lab, depending on where I can find funding. That's another thing I didn't talk very much about, is that you really have to follow the money. If there's a research area that you're interested in, but there's no funding, there's no labs that have funding, then you may need to find something that's related if possible, but a little bit different. Or maybe do something with the same technology in a different area so that you can maybe apply it later. So that's where I am right now. I'm thinking about how to continue in academia for another 2 or 3 years, and then hopefully become a professor in the future. My dream research project, if you remember, I asked the question about a magic pill that could solve language deprivation. Not necessarily a pill, but I'm very curious about how we can provide cognitive recovery. So for deaf people who were exposed to sign language growing up, they have that protection against dementia and against the other issues that we see with language deprivation. Now, what if we could capture those skills and teach them to other people, or people with IDD, or people with autism? So people with autism struggle to understand other people's body movements and the social significance of them. So is there something that we could teach them that would help them understand and interpret that information? It wouldn't be a magic fix, but it would be a way to provide foundational skills that could lead them to a better quality of life in the future. Because obviously sign language is very cool. I love sign language. I love the brain. I would love to think about how we can improve our brain. Our brain is amazing. And I'm thinking of what we can capture that's innate in our brains and share with other people who don't necessarily have those innate capabilities. Thank you for asking. Thank you so much for your time. I'm so glad that you could come and give this talk for us today. I really appreciate it. Thank you so much.